Okay, we've got a worked example here for a binomial hypothesis test, and in this hypothesis test, we've got a six-sided dice, and Bryony suspects that it's biased in favour of 2. So what she's going to do is she's going to throw the dice 35 times and note the number of 2s, and then she's going to carry out a significance test. This being at 4% significance level. Find the rejection region for the test. Right, okay, so we're not actually doing the test here, we're just laying the ground rules. This is the proper and correct way of doing it, is to actually decide your hypotheses before you run the test. So what have we got? So we're going to form our hypotheses. Well, what she's trying to disprove is that it is a fair dice. So our null hypothesis would be that the probability of a 2 would be 1/6. Okay, so our random variable here would be the number of 2s thrown in a set of 35. So that would be our null hypothesis. Our alternative hypothesis, now she believes that it's greater than 2. So our alternative hypothesis would be that that probability is greater than 1/6. And that would lead us to a one-tailed test. Note this greater than here, one-tailed test of 4%. So as I say, the random variable is the number of 2s thrown out of 35. So the random variable would be binomially distributed with an n sample size of 35 and a p probability of 1/6. Okay, so we can get our calculator out and enter these parameters into it. So what we want is we want a selection of values. So we're going to go for a list here, and here's part of the list. So this gives the probability. This first row gives the probability that the random variable, number of 2s, is going to be less than or equal to 7, and that's going to be 0.7818. So the probability, therefore, is that the random variable is 8 or more would be 1 minus this. Okay, so if we look down here, this is getting into the territory that we're interested in. So the probability that it's going to be less than or equal to 9 is 0.945, meaning the probability that it's greater than or equal to 10 would be 1 minus this, which is 0.055. And then we got another reasonable option here, which is 10. So the probability that it's less than or equal to 10 would be this 0.9768, leaving a probability that it's 11 or more of 0.0232. Okay, so those are our best candidates. If we look at these, well, there's not much in it really, is there? But we would say that this one is closest to 4. So we're going to adopt this one. It's actually going to give us an actual significance level of 5.5%. And as with these binomial hypothesis tests, the significance level that you first given or you first decide is only going to be for guidance. Really, it's really determined by the distribution. So our rejection region is going to be the region of 10 or more. So if we do our test and we get 11 or more 2s, then we are into the realms of something which is going to be pretty unlikely and unlikely enough to cause us to reject the null hypothesis and conclude that Bryony's suspicions are probably correct. So that's what we've got. Rejection region is the random variable is greater than or equal to 10, and the significance level is 5.5%. So hopefully that has been useful. Thanks for listening.